the module 2 of the course integrated circuits and applications. And the module 2 is temperature ranges, power supplies, and the ordering of an IC information. So these contents we are going to discuss in module 2 of the course integrated circuits and applications. So after completion of this lecture, students can be able to learn the temperature ranges and the power supplies of the various ICs, and also able to learn the ordering of an IC information. In the first the module 1, we discussed the classification of ICs by using various factors, and we have seen the different types of packages also. The first package, if you see, that is flat package. So we learned that flat package is suitable for military and aerospace applications. Similarly, dual inline package, we have seen that it is suitable for commercial applications. Like that, we have seen varieties of, discussed some of the ICs which are suitable for specific applications. So whatever the all these ICs falls under 3 temperature range application. So first one is military application, whose temperature range is from -55 degrees to 125 degrees Celsius. Similarly, if it is industrial application range, it is from -20 degrees Celsius to 85 degrees Celsius. And if it is commercial application, it's from 0 to 70 degrees Celsius. And let us see the ordering information of an IC. So generally, any IC, it's represented with various initials. So in order to define an IC by seeing its initials, you can see here one example. It is first one is BUA741TC. In this, you can observe several alphanumeric characters which is separated from some more alphabets. The first alphanumeric characters represents the device type. So in this, the alphabets represents the type of the manufacturer, and the next digits represents, or the numericals represent the device information. And BUA741, BUA represents that, the initial represent that it is a Fairchild manufacturer. And the device information 741 represents that out of 8 pins available in 741 IC, there are only 7 active pins and 4 inputs and 1 output. So that's why it is stated as IC741. And later you will have some space here followed by TC, where T represents the package type, and that is here it is mini dual inline package. And C represents that the temperature range is suitable for commercial applications. That is commercial temperature range, that's from 0 to 70 degrees Celsius. And here you can see another example of IC ordering. So that is MC34001PC with some space followed by PC. And MC34001 represents the device type, where MC represents that the manufacturer is Motorola, and the device information is, it represents the series of the particular IC. And P represents the package type. Here it is dual inline package, plastic dual inline package. And again C represents the commercial temperature range. And you can see one more example, that is LM101AF. Here LM101 represents the device type, as we already discussed, and the LM is the initial provided by National Semiconductor. And here 101 represents the military temperature range. For example, if it is industrial temperature range, it is defined by the numerical 201. And if it is commercial temperature range, it is defined by initial 301. And followed by some A, it represents that it is advanced version. And F represents the type of the package, that is flat package. And this is suitable for military applications, because the temperature range is military temperature range. So like that, the initials here you can see several initials provided by various manufacturers. So here it is Fairchild manufacturer, it is BUA, BUAF. And if it is National Semiconductor, the initials given are LF, LH, LF, and TPA. If it is Motorola Semiconductor, the initials are MC and MFC. If the initials are Texas Instruments, the initials are SN. If it is Radio Corporation of America, the initials used are CA and CD. And if it is Siliconics manufacturer, the initials used are L. If it is Sprague manufacturer, the initials used are ULS and ULX. And if it is Intersil manufacturer, the initials used are ICL and IH. If it is Signetics, the initials are N by S or NE by SE or SU. And if it is Burr-Brown, the initials used are BB. So in the similar fashion, a particular IC 741 provided by various manufacturers, even though they have different initials, they possess the same specifications and their behavior is also same towards the application. But a National Semiconductor is represented by LM741, and Motorola is represented by MC1741, and RCA, like Radio Corporation of America, it is stated as CA3741, and Texas Instruments SN52741, and Signetics N5741. So like that, whatever may be the initials provided by the manufacturer, it possesses the behavior of the IC remains the same. And the various external versions of 741 are 741C, that is for commercial, and 741A and E, those are the advanced and improved versions. 741S, it is military with higher slew rate, and 741SC, that is commercial with higher slew rate. Now you can see the power supplies of linear IC. Generally, a linear IC will have both positive as well as negative power supply. For example, if you take IC 741, it will have both positive as well as negative power supply, and those power supplies are equal in magnitude. Here you can see if it is Motorola, defined by Motorola manufacturer, the initials are plus PCC and minus PEE, whose magnitude is same, that is plus or minus 50 ohms. And that magnitude may range from plus 4.5 volts to 18 ohms. Generally, it needs positive and negative, but sometimes the magnitude may be different. That is, a best example is IC702. And some ICs need only positive power supply, and that example is IC324. But whenever a single power supply is used, it is necessary to connect an extra circuit to the IC. Here you can see the power supplies of a linear IC. Here in the figure, if you observe, it has non-inverting input as well as inverting input, and the two power supplies equal in magnitude with respect to positive and negative magnitudes, and you are taking output at 6th pin, and the two power supplies are connected with the external voltage divider network or potential divider network to adjust the characteristics of the IC, the particular IC. So in this module, I think the students have learned the various temperature ranges and the power supplies of an IC, and also the students have learned the ordering of an IC. By observing the initials, I think students can recognize the type of the manufacturer used. Thank you for listening.